Next, we talk about logarithmic functions. So logarithms and inverses and exponentials are inverses. So that's why we speak about them together now. They undo each other. Just like multiplication and division are inverses, addition and subtraction are inverses, squares and square roots are inverses, logarithms and exponentials. Log and exponentials are inverses of one another. They undo. So I can take a logarithm, which looks like this, y equals log base b of x, and rewrite it as an exponential, which looks like this, b to the y equals x. So when you do this, you want to think about this b to the y equals x. So we're not going to use b to the x. If they were together inside the logarithm, they're not going to be together when you rewrite them. So log base b of x is equivalent to b to the y equals x. So we're going to use that property. We call this the definition of the logarithm. So when you see this later, if they ask you to use the definition, that's what you're doing. You're just taking a log and rewriting it as an exponent, or taking an exponent and rewriting it as a log. So take these following logarithmic equations and write them as exponentials. So here's my base b, so it stays my base. And my exponent becomes this 1/2. So 6 to the 1/2 equals square root of 6. Same thing over here. Here's my base b, and this guy becomes my exponent. 3 to the 2nd equals 9. Now over here, b was my base, 2 was my exponent. So this is going to look like log base 5 of something equals 2. And that 25 is what goes inside of there. Because again, I'm using this expression, these equivalent items, and just matching. Okay, here's my base 2. Here's my, here's my exponent, -1. So when I rewrite this as a logarithm, I get log base 2 of something equals -1. And that inside piece is what comes after the equals. That x is 1/2. So how can I evaluate logarithms? So what you could do is you could think about, if you want to find y, you rewrite this as 4 to the y equals 64 and say, what number do you have to put in there to get 64? Well, I know that 4 to the 3rd is 64, so this is going to be 3. The other option is you can just put this in your calculator, log base 4 of 64. So go to your calculator, go to functions, look for the one that says log base 4 of 64 spits out to us 3. So log base 4 of 64 is 3. I can do this next one, log base 3 of 1 over 27. So log base, if you're typing on a keyboard, this is a little bit easier even. 3 of 1 over 27 is -3. Okay, so two kinds of logarithms that appear a lot are the common logarithm and the natural logarithm. And so when we have special symbols for these, the common logarithm is a logarithm with base 10, and we write it with just log x. We don't put any number down there, okay? So when you see something that says log x, what it really means is log base 10 of x. The other one is the natural logarithm, and that's a base e, so ln of x. So when you see something with ln of x, what it really means is log base e of x. But these are special buttons on your calculator. There's one that says log, there's one that says ln. You don't have to use that log base button when you're evaluating these. So let's evaluate these two expressions. Log of 0.001. So really what that means is log base 10 of 0.001. In our calculator, we're going to look for the log button, just the one that says log. So I didn't put the base in there. And when I put in 0.001, I get -3. Same with this guy. This is log base e, natural log is log base e of 1 over e to the 4th. Okay, so I'm going to do log base e, or natural log So under my functions, I'm going to look for the one that says natural log, ln, of 1 divided by e to the 4th. Gives me -4. So pay careful attention when you're doing logs to see what is that base. If they don't tell you a base, it's base 10. If they use that ln symbol, then it's base e.